Okay, this is the P4 paper from October 2023. It's question number 5, and this is an implicit differentiation question. We've got a curve C with the equation given by that function there. K is going to be a positive constant. I think I used that in part B. But part A says, can we find dy by dx? So absolutely, if I want to find dy by dx, I need to be able to differentiate these 4 terms here, and actually the only one that's going to cause me any difficulty is going to be that one there, because it's going to be a product, and I'll go ahead and do it, and you'll see that what I want to do is to try and tackle this quite quickly and not spend ages over the product part of it. But let's write the function out first of all. We've got y cubed minus x squared plus 4x squared y is equal to k. So if we're differentiating them all, differentiate y cubed, so multiply by the power, take one off the power. Because it's a y function with our implicits, we have dy by dx there. Differentiating x squared should cause nobody any difficulties. And then we come to this product here. So you should be really good at doing the product rule by now. So I'm just going to do this as being u dv dx plus v du dx. So u dv dx, u is 4x squared, and dv dx, the differential of y, is dy by dx. Plus v du dx, well, v is just y on its own, and the differential of 4x squared is just going to give me a x there, is equal to the differential of k, well, that just goes, so no problem with that. Yeah, and when we get these, say, you should have done quite a lot of practice of these ones, I can see now I've got 2 terms that have got dy by dx in. So let's leave those on one side. So 3y squared dy by dx plus 4x squared dy by dx, and get everything else over to the other side. So in this particular example, 2x minus 8xy there. Take dy by dx out as a factor now, which is just going to leave me 3x squared plus 4x squared there. And again, 2x minus 8y here. Should be really familiar to you what I'm doing here. So dy by dx is just my 2x minus 8y, all divided by 3y squared plus 4x squared. So I've managed to get dy by dx in terms of x and y. Not unusual at all. Right, part B then says, point P lies on C. Yeah, I can see that. The normal to C at P has the equation y equals x. You can see that as well. Can we find the value of k? So it just takes a little bit of unpicking to work out what we've got to do here. So if the normal is y equals x, then I know the gradient of that line is m equals 1, which means if I were then to draw the tangent in at P, I'd know that that gradient is going to be m equals minus 1, because these two are perpendicular to each other. So that means I know that the gradient of the tangent, that dy by dx at P, is equal to minus 1. So what I've really got to do now is to actually work out what point P is. Well, point P, if it's when the gradient is equal to minus 1 there, that's how I'm going to work it out. I've got my function here, there, so I can say that's going to be equal to minus 1. And remember, we also know, because it's on the y equals x line, we know that x is equal to y. So I'll be able to put x equals y into that, or y equals x, doesn't matter which way around we do it, and we're going to get an equation we can sort out. Okay, I've said that quite quickly, so let's now explain it to the examiner. And then while I'm doing it, you get a second chance at listening to what I just said. So what we're going to say is, the gradient of y equals x is equal to 1. So the gradient of the tangent at P is minus 1 over that, but realistically is minus 1. And because P is on the line y equals x, we know that either x equals x or y equals y. It doesn't matter which one we're going to choose there. It's going to be, or rather it's going to be the point xx. It's a slightly easier way to explain it to the examiner. It's the point xx or yy. And because I know that this part here, because I know the gradient of the tangent is there, what that then means is if I go back to my dy by dx, so dy by dx, which was 2x minus 8xy all over 3y squared plus 4x squared, I know that that is going to be equal to -1 at this point or at this point. So you can either get an equation in x's or an equation in y. I'm going to get an equation in x's. So this is going to be 2x minus 8x x is equal to -1 over 3x squared plus 4. Leave the 4x squared like that. So the reason I put those brackets in, hopefully to make it clear to the examiner, I'm subbing in that y is equal to x here, and I've just got something I need to be able to solve. So what have I got? I've got 2x minus 8x squared all over 7x squared is equal to -1. So that's 2x, careful with handwriting, minus 8x squared equals minus 7x squared. So that's, if I tidy that up, x squared minus 2x is equal to 0. I'm taking everything over to that side. So I'm going to get x, or x minus 2 is equal to 0. So I get my two possibilities. X is equal to 0 or x is equal to 2. But if we go back to the diagram, that's clearly not the point 0, 0. It is the point 2, 2. So if I've got that situation, then I can now say P is the point 2, 2. So if I go back to my original equation here, then I know that when x is equal to 2, y is equal to 2, so I'll be able to work out what k is. So sub that into the equation. Might as well write the equation out, again, just to make it clear to the examiner what we're doing. Y cubed minus x squared plus 4x squared y is equal to k. This would be the other reason why we know that x is not equal to 0, because otherwise you get 0, 0, 0, 0 there, so k wouldn't be positive. But we're now just going to sub in. So 2 cubed, 2 squared, 4 lots of 2 squared times 2 is equal to k. So k works out to be equal to, if you do all those, it works out to be equal to 36. Okay, so let's just have a look. Yeah, that's everything done. We worked out dy by dx, and then we worked out the value of k, and it is a positive value. So hopefully all of that makes sense to you.